This is Higher Maths, it's practice paper F, and we're looking at question 1 in the calculator paper. Here we go. So find the equation of the tangent to the curve y is equal to x cubed minus x minus 10 at the point where x equals 1. We've got 5 marks that we're going to get for this one here. Right then, so the way I'm going to approach this one here is that we've got a curve, and what I'll do is I'll differentiate. If I differentiate, I'll substitute the point x equals 1 into the differentiated equation, and from there I should be able to find out the gradient, because that will be my gradient equation as well. When I've got the gradient, I'll then find the point of contact by substituting the 1 back into here to find what y is equal to, and substitute into the equation of a straight line. Right, let's go ahead and do that. Right, so for part A. Right then, so starting off with the equation, y is equal to x cubed minus x minus 10. We'll differentiate first, and that should give us 3x squared, and that'll give us minus 1. So remember that there is also my gradient equation that's there. Right, so I'm going to substitute in the point 1, okay, the x value of 1, so that I can find out what the gradient's equal to. So 1 squared is 1 times 3, and that's going to give me, taking away the 1, gives me 2. So the gradient is going to be equal to 2. Right, so what we'll do now is I'll find out the y coordinate of the point of contact. So what we'll do is I'm going to substitute a 1 in wherever I see the x values. So that's going to be 1 cubed, and that's going to be minus 1 minus 10. Okay, so that'll be 1, take away 1, and that's 0, so that'll give me minus 10. So my point of contact for this part here is going to be 1 minus 10. Right, from there, what I'll do is I'll substitute the gradient. So substitute the gradient equal to 2 and the point of contact, which is 1 minus 10, into the equation of a straight line. So that's y minus b equals mx minus a. Okay, so that'll be my point A, that'll be my point B. So it'll be y, and that'll be plus 10, and that'll be m, which is my gradient, 2x minus 1. And that's where I would expect to get my mark. What I'm going to do is I'm going to prepare that a bit further, because I can see I've got to do some work here with this equation of the tangent. So I'll multiply out that side by 2. So that'll be 2x minus 2, and what I'll do is I'll get y is equal to 2x, bring the 10 over, that'll give me minus 12 there. Right, so that's the part A complete, okay, and I would expect to get my mark at this level here. Right, let's go for B. So B says that we have to show that this line is also a tangent to the circle with this equation here, and we'll state the coordinates of the point of contact. Right, so let's go ahead by substituting instead of y here, we'll put in 2x minus 12, and from there we'll be able to work out the x coordinate of the point of contact. And we should get that to be one point of contact, and if we do, we'll make a statement and find out the y coordinate based on that. So let's go for part B. Right, so what we'll do first of all is we'll substitute y is equal to 2x minus 12 into the circle equation. Okay, and what we've got here is we've got x squared, that's going to be plus, so instead of y, what I'm going to put in is 2x minus 12, square that, minus 6x, and then I've got minus 8 times y, and again what I'll do is I'll substitute 2x minus 12, and from there I've got a plus 5, and that equals 0. Right, what I'll do is I'll square this bracket out, and I'll multiply this bracket out on the next line, and that's what we'll go for here. So I've got x squared, that's going to be plus 4x squared, that's going to be 24, so that'll be minus 48x, that'll be plus, because I've got minus 12 squared will be plus 144. What I've got then is minus 6x, minus 16x when I multiply this bracket out, plus, and that's going to be plus 96, plus 5 equals 0. From there what I'm going to do is I'm going to gather up what I can, so the x squared terms, so that'll be 5x squared, the x terms that I've got there what I'll do is I'll get that together, and that'll be minus 70x, and just the basic number terms that I've got here, and that should give me 245, yeah, plus 245, and that all equals 0. I've now got a trinomial that I could factorise, or I could well, what I could do is I could use a discriminant to show that it's a point of contact. What I'm going to do is I'm going to find that there's only one point in this question here. So I'll take out a common factor of 5 just to make things a bit easier for myself. So 5 into 70 will give me 14, so that'll be 14x, and 5 into 245 should give me 49, so that'll be plus 49. Right, what I'll do is I'll factorise this part here first of all. So factorising that, x and x multiplied together, I get that. Two numbers that multiply together get 49, difference of 14, 7 and 7. And I really am only looking for one point here anyway, and I have to show that it is, so I really would expect these two brackets to be the same. So what I've got here is I've got 7 and 7, these two multiplied together to get the 49, and they're either both positives or both negatives. That tells me they're both negatives. Okay, so from there what we've got is we've got 5x minus 7 squared equals 0. So x minus 7 equals 0, so x value equals 7. So let's work out the point of contact. So I know I've only got one point of contact here, and I'll work out that point of contact first and then make a statement to show that the line's a tangent. So what we'll go for is for the point of contact, we'll substitute x is equal to 7 into the tangent, into the straight line, which is y is equal to 2x minus 12. So what we have here is we've got y, when we substitute 7 in for x, is equal to 2 times 7 minus 12. 14 minus 12 will give me 2. So that gives me the point of contact. So the point of contact here is going to be 7 for x, 2 for my y. That's that. Right, from here what we'll do is we'll just make a statement. So since there's only one point of contact, and that point of contact was 7, 2, I'll say that the line y is equal to 2x minus 12, so that's 2x minus 12 is a tangent to the circle, and the circle goes x squared plus y squared minus 6x minus 8y plus 5 equals 0. And that's the question complete. So there's 11 marks in total here. Let's look for the 5 marks that we're going to get in part A, and let's go for, first of all, we'll go for differentiating here. We'll go for 1 mark for substituting the 1 in there, and 1 mark for getting the gradient. We'll go for another mark for getting y is equal to minus 10 when we substitute 1 in to get the point of contact, and finally we'll get 1 mark here for getting this line, so that'll be y plus 10 equals 2x minus 1. Or if you've taken it that bit further, that's fine, we'll get the mark there. So it's 1, 2, 3, 4, 5. Let's look at the 6 marks over this side here. So the first mark will be given when we substitute in these parts here. So I'll go for this line here, and that's the substituting y is equal to 2x minus 12 into the circle equation. I'll then go for a mark for gathering things together and multiplying them out and getting it to that form. Take a mark for factorising that to there. Get a mark for getting the x is equal to 7, and we'll go for, let's see what we'll go for. We'll go for the point of contact here. So getting the point of contact as 7, 2. So what we'd have to do is this part will work here and the point of contact. Finally, a mark here for showing that the point of contact, the line is a tangent to the circle. So in total here, this is out of 11 marks. Remember, in this area here, to show that it's a tangent to the circle, the straight line, what you can do is use the discriminant. In this case, I've just shown that there's 1 point.